Imagine waking up to global headlines claiming that the James Webb Space Telescope has just detected thrust coming from an interstellar object hurtling toward our solar system. 10 light years away, they said, and moving closer to Earth. The name of this mysterious traveler, 3I Atlas. The claim alone sent shockwaves through the scientific community and social media alike. Was this just another comet from deep space or something deliberately steering through the void? Before we jump to conclusions, here's what's real, what's theory, and what this discovery could actually mean for humanity's understanding of interstellar motion. The James Webb Space Telescope, designed to look back in time to the origins of the universe, turned its infrared eyes toward something much closer, 3I Atlas, the third confirmed interstellar object ever detected. The first was Oumuamua in 2017, which baffled astronomers by accelerating without a visible tail. The second 2I Borisov looked like a more conventional comet. Now 3I Atlas appears to be rewriting the rules yet again. Webb's ultra-sensitive instruments captured faint but consistent emissions, tiny changes in movement that hinted at a gentle, continuous thrust-like force. That observation was enough to ignite a storm of debate. Is this a natural phenomenon, or could it be a clue pointing to something more? Early data show that 3I Atlas is following a hyperbolic trajectory, meaning it's not bound to our solar system. It came from the stars and will return to them once it passes the sun. Its estimated size ranges from a few hundred meters to several kilometers, surrounded by a cloud of gas and dust consistent with frozen volatiles like water and carbon dioxide evaporating under sunlight. But what caught astronomers' attention wasn't its composition, it was the way its path didn't quite match expectations. Traditional gravitational models couldn't fully explain its subtle deviation, and the data hinted at a slow, steady acceleration unlike the chaotic jets typical of comets. It wasn't random, it wasn't sporadic, it was unnervingly consistent. If this thrust was natural, it might be caused by directional outgassing vents releasing gas in specific patterns due to the object's shape or rotation. But some scientists argue the pattern looked too deliberate, too balanced, almost as if something was adjusting its course. That's where imagination and science began to collide. Some proposed that the thrust could be the result of new physics in ice sublimation, a previously unknown way frozen materials react under cosmic radiation. Others more daringly wondered if we might be witnessing an engineered phenomenon, a remnant or probe built by an ancient civilization. Yet even the most skeptical researchers admit one thing: whatever is happening with 3I Atlas, it's forcing us to rethink how matter behaves in the cold emptiness between stars. And that's where the investigation begins. Over the next few months, telescopes around the world will track its every move, especially during its close pass near Mars, a perfect opportunity to measure any change in trajectory with unprecedented precision. If a consistent thrust continues, scientists will have to consider whether this interstellar traveler is more than just frozen debris. Could nature itself be teaching us how to travel between stars? Or have we just witnessed the quiet signature of something not made by us at all? The truth is still unfolding, but one thing is clear. This is not just another comet story. It's a challenge to everything we thought we knew about motion, life, and intelligence in the universe. What if the first real contact humanity ever experiences doesn't come as a message, but as a moving object silently passing through our sky? To understand the magnitude of what James Webb may have uncovered, we have to look beyond headlines and into the mechanics. Detecting a thrust-like force in an interstellar object is no simple claim. It demands precision far beyond what traditional telescopes can achieve. The Webb telescope's infrared spectrometers can detect temperature variations smaller than a degree and motion shifts measured in centimeters per second. When applied to 3I Atlas, this allowed astronomers to observe subtle thermal imbalances that suggested energy release in a consistent direction. Imagine sunlight hitting one side of the object, heating patches of ice buried beneath its crust. As that ice vaporizes, gas escapes through microfissures, creating a tiny push, like a slow exhale in space. Most comets behave this way, but their jets are uneven, unpredictable, and tied to the rotation of the body. In contrast, 3I Atlas's thrust seems steady, as though its outgassing was somehow regulated. Scientists at multiple observatories began to cross-check this anomaly. Could it be a measurement error? Could gravitational interactions with smaller bodies explain the deviation? Initial recalculations confirmed the pattern small but persistent. That was enough to open the door to deeper analysis. One possible explanation points to surface architecture structures formed over millions of years in interstellar space exposed to radiation and cosmic impacts. These could have created intricate channels that vent gas in a fixed direction when heated, mimicking propulsion. If that's the case, 3I Atlas might be our first look at a self-regulating natural thruster, a comet whose geology creates mechanical behavior by accident. But the alternative is far more provocative. If 3I Atlas were artificial, the uniformity of the thrust could represent controlled movement, a way to correct trajectory to aim or to stabilize. That concept isn't science fiction anymore. Even humanity's own probes like Voyager and New Horizons use similar continuous low-thrust adjustments. If a civilization older and more advanced than ours had launched such an object millions of years ago, it could now be passing us completely unrecognized. This is why Webb's observation carries such weight. It's not just about confirming a data point. It's about testing the boundaries of natural law. The scientific community's reaction has been a mixture of excitement, skepticism, and caution. Some teams call it the most important interstellar observation since Oumuamua, while others urge restraint, warning against the temptation to label the unknown as alien. Forums, think tanks, and university seminars have exploded with new models. Could 3I Atlas be demonstrating solar-assisted drift propulsion, where a porous body passively channels heat energy to sustain its motion, or perhaps an electrostatic effect, where charged particles build pressure beneath its crust and release at precise intervals? Whatever the cause, this object's motion is rewriting orbital textbooks in real time. Data from Mars orbiters, space telescopes, and ground-based networks are now being synchronized to calculate its exact non-gravitational acceleration, if any. So far, numbers hint at something in the range of a few millimeters per second squared, minuscule but meaningful if sustained over time. That might not sound dramatic, but in space, even the faintest push can shift a path across millions of kilometers. In cosmic terms, persistence equals power. And in that persistence, scientists see either nature's ingenuity or a whisper of intention. As Webb continues to collect infrared readings, one thing is clear: every second that 3I Atlas remains visible is a chance to decode a mystery from beyond the stars. Could we be witnessing physics that evolved naturally across light years, or an ancient design drifting through the cosmos long forgotten by its makers? The deeper the data dives, the sharper the divide becomes between those who see 3I Atlas as a natural wonder and those who suspect something more deliberate. The tension echoes the controversies that erupted after the discovery of Oumuamua, an object so strange that it left even seasoned astronomers torn between physics and possibility. At first glance, 3I Atlas behaves like a comet. It releases gases, brightens as it approaches the sun, and shows no clear technological signature. Yet beneath that familiar behavior lies an unsettling consistency that refuses to fit the standard cometary template. To many scientists, this is where the story turns from astronomy to philosophy, because it challenges how we define natural. If a body from another star system can shape its own trajectory through slow, controlled energy release, does that make it an engineered mechanism or simply an example of cosmic evolution, discovering efficiency? Researchers from multiple agencies are now simulating every scenario they can imagine. Some argue that 3I Atlas may have developed crystalline layers or tubular voids after billions of years of exposure to cosmic radiation structures that could focus heat and outgassing like miniature engines. Others note that this could be a byproduct of its rotation. If the object spins on an uneven axis, it might vent gases in a repeating rhythm that appears deliberate but is actually natural clockwork. However, the more these hypotheses multiply, the clearer it becomes that we are peering into a gap in our understanding of interstellar geology. Every model designed for solar system comets breaks down when applied to travelers that have wandered between stars for eons. Their material, shaped by alien suns and unknown forces, might behave in ways that defy our expectations. Still, the specter of artificial origin refuses to fade. Engineers studying Webb's data have pointed out that the consistent thrust profile of 3I Atlas mirrors what humans might design for a slow, fuel-efficient interstellar probe, something relying on continuous sublimation or solar heating to maintain direction over millions of years. And if such an object exists, it may not be the first or last. The notion of interstellar traffic objects drifting through space as remnants or couriers has moved from fringe speculation to a legitimate scientific question. Could there be a silent network of messengers crossing the galaxy long before humanity learned to detect them? Or are we merely seeing the diversity of cosmic behavior for the first time, now that our instruments are precise enough to capture it? The conversation isn't just scientific, it's cultural. The public imagination has erupted with fascination and fear. Some interpret Webb's discovery as proof that alien technology could exist right under our noses, while others see it as a humbling reminder that the universe is far more inventive than we are. Governments and research agencies have issued statements urging calm, reaffirming that there is no evidence of hostile intent, just unexplained data. Yet behind closed doors, it's undeniable that defense organizations and space agencies are watching closely. If an object from another system can generate sustained motion without engines, that technology, whether natural or not, represents a breakthrough in propulsion physics. Scientists call it passive thrust, but to the rest of us it feels like a quiet revelation. Maybe nature itself has already solved interstellar travel. The philosophical weight of that realization is staggering. For the first time, we might be witnessing a bridge between biology, geology, and engineering proof that the universe produces complexity that looks intelligent even when it isn't. And yet, if it is intelligent, then everything we know about cosmic solitude collapses. Somewhere out there, someone or something mastered motion through the stars using forces we barely comprehend. The question no longer is whether we're alone, but whether we've already been noticed. As 3i Atlas continues its silent journey past Mars and out of our solar system, humanity finds itself standing at the edge of a profound revelation. Whether its thrust is the product of natural outgassing or an ancient act of design, the discovery has already achieved something extraordinary. It has expanded the boundaries of our imagination and our science. Telescopes worldwide remain locked on the object-gathering data that will feed simulations for years to come. The James Webb Space Telescope, originally built to gaze at galaxies born billions of years ago, is now teaching us that some of the greatest mysteries lie much closer in small, fleeting travelers that visit us from the stars. If the thrust of 3i Atlas proves to be purely natural, it will revolutionize our understanding of interstellar geology, revealing that cosmic radiation rotation and thermal reactions can sculpt matter into self-propelling forms. That discovery alone could inspire new models for spacecraft propulsion, mimicking the subtle persistence of this object's motion. But if the thrust cannot be explained by physics as we know it, the implications stretch even further. It might mean we've just recorded evidence of ancient engineering, a relic of a civilization that learned to travel between suns without leaving a trace of communication. And that thought, terrifying to some, exhilarating to others, forces humanity to confront a new kind of humility. In both possibilities, the message is the same. The universe is alive with forces and stories we have yet to understand. The data Webb captured is not just an observation, it's an invitation. It urges us to keep watching, to keep questioning, to accept that wonder and fear often live side by side. One faint push from a distant traveler has changed the conversation forever. And now the question that echoes through every observatory, every lab, every mind that looks up at the night sky remains. What if this isn't the last interstellar visitor with a secret to tell?